Hey everybody, what's good? What's going on? JB here, back with another CyberInsight live stream. And today we're going to be doing another one of my Cisco CCNA CCNP Lab walkthroughs. And we're going to be focusing again on OSPF. So if you checked out the stream last week, kind of went through a lab. I showed you my GitHub repository for these labs where we got some configs to start with, some diagrams that lay out the tasks. And then the final configs got the same setup going on again today. So the link for that is in the video description. Not necessarily going to dive into all the specifics of that since we kind of laid that all out last week. So just going to hop over into the lab. If you have any questions as we're going through it, throw it in the chat. And as always, appreciate you checking out the stream. Make sure you smash the like button, subscribe, all that other good stuff. So today's lab, we're going to be doing a few different things. We're going to be enabling OSPF again, creating some different areas. This time we're going to be doing a totally stubby area versus last week we did a not so stubby area. We're going to talk about the differences between those. We're also going to do some things to kind of improve the failover response within some of these areas with some dead timers. And then we talked about last week a little bit the challenges of having an area that's not connected to the backbone. So in today's lab, we're going to actually be using GRE tunnels to make connections from a disparate area back to area 0. We're also going to be looking at doing some weighted routes for failover purposes, and then obviously some OSPF troubleshooting and verification commands as we go about implementing all of these different configurations and moving through these tasks. Again, this isn't necessarily going to be a OSPF 101 type of video. We are going to hit on things as we're moving through, but ideally you do have a little bit of background in understanding some of the fundamentals about OSPF. If not, don't worry. The things that we are hitting here, and then I might just kind of point out a few quick points, have a whole bunch of different source websites that are in the description as well for you to kind of go a little bit more in depth into these particular topics. So let's just hop into this right off the bat. The first task that we have here, obviously setting up the host names, interfaces, and IPs. We already got this all taken care of, so we actually don't need to go and implement this. If you are following along and doing this in your own lab, all you have to do is go to the base config section here, and you already will have all the configs already set up with the IP addressing the way that it needs to be. So pretty much straightforward there. We will just kind of walk through this just to give you an idea of what's going on here. So we have area 0, which is going to be the /29.10.0.1 network with a .1 on router 1, .3 on router 3, and a dumb switch kind of connecting the two of these. So this is our backbone area. Off of router 1, we're going to have another /30 going into area 2, which connects router 1 and router 2. And then over off of router 2, we're going to have a separate LAN that's kind of a separate VLAN off of that, this 192.2.0/24. You'll notice, as I mentioned this last time in the video, I try to make all of this numbering kind of make sense here. So any type of VLANs and stuff like that that we're having hanging off of different routers is going to try and match it to whatever the router number is. So in this case, router 2, the network is going to be a 2 network. Router 4, the network is going to be a 4 network. And then also when we're doing the router IDs, we're going to keep those similar to the router names as well. So router IDs on router 1 is going to be 1.1.1.1, and then on 2 is going to be 2.2.2.2, 3, 3.3. You kind of get the point. And we talked about the router IDs last week and kind of what's needed for each of those and the purpose of those. So we're not necessarily going to go back into that today. So off of router 2, we do have another connection down to router 4. This is within area 1. And then again, another VLAN hanging off of that. You'll notice a difference between these this week and last week is this area over here is now area 1. I believe last week area 1 was up on the top. You'll also notice that the LAN segment over here off of router 2 is actually within area 2, where last week it was not, and we had to do a not so stubby network in this upper area here to be able to get an external route in for this VLAN. So we actually won't have to do that this time. Another difference is this WAN link now does not actually reside within any of the areas. So that is something of note, and we'll kind of see how that kind of comes into play here. So since we know that we have the host names and interfaces and all that stuff hooked up and good to go, we can just kind of move into our next task with number 2. So the main thing that we're going to be doing there is we need to configure OSPF area 0 on the LAN segment that's connecting router 1 and router 3, or I should say router 1 and router 1 and router 3. And then to allow for faster convergence, we're going to want to configure OSPF to detect neighbor failures within 1 second. So we're going to set the OSPF dead interval to 1 second. And we also want to make sure that the router sends 4 hellos within every second. So there's going to be some timing configuration that we're going to have to do there. So let's hop in to the actual lab and get that started. So we're going to go into router 1, get in here. And we're just going to take a look and make sure all our interfaces are up. They are. So we were going to configure OSPF 1 on this. So we can go conf t and then router OSPF 1. Remember, the instance that you're using for OSPF really doesn't matter. They don't need to match between all the different devices. And again, just keeping with the numbering scheme on these, it makes it just easier to match with whatever the router host name is. So we're going to do that. And to kind of help speed things along at this point, we're also going to go and just copy out the necessary configs to move these over as we do this. So we are going to do router ID 1.1.1.1. Make sure that we are where we need to be. And then we need to do the configuration on the specific interfaces. So we can go and take a look and see what we had on here. So it was 03. Pretty much we're just going to go IP OSPF 1 area 0. And then the timer configuration here is kind of interesting. So there's a few different things that we should probably explain here. So if we go IP OSPF dead interval minimal, this is going to go to the minimal setting, which is actually going to be of 1 second. And then the hello multiplier is how many hellos are going to be sent within that time period. So in this case, it's going to be 4. So we're just going to take these two and GI 0/3, go into the right interface. We should have that there. And now we can go over into router 3 and pretty much do the same thing. Router OSPF 3, router ID 3.3.3.3, int GI 0/3, and it's going to be the same configuration here. So, and we can actually at this point do the show IP OSPF neighbor command. And we'll see that we do have a full state. So that means that we are sharing stuff back and forth. And we see the designated router selected for the neighbor. Also, dead timer is interesting. If we keep doing this, we'll see that the timer here is actually, the value is going to be less than 1 second for the dead timer. So we see that that really is sending it every second. Let's see if there's anything else that we kind of want to verify with that. I think if we actually show, do show IP OSPF interface. GI0/3. Be able to see some other interesting information that might be helpful here to verify what we're doing. And we actually can see time intervals configured, and we see that the hello is set to 250 milliseconds. So that's because we're sending 4 every second. Let's see if there's anything else. I think we could also maybe do a similar type of command if we wanted to. So we could do a do show IP OSPF neighbor detail. And again, let's see. Okay, so the issue here, again, we run into this because of the fact that the session was created before the router ID was put on there. Do clear IP OSPF. Let's see. Clear IP. And that is 1. Process. Yes. Now if we run this again, so show IP OSPF neighbor detail. Let's see, why is that not coming up with the right router ID? Let's take a look at this real quick. And just make sure that we have that router ID set properly. Well, for some reason we have router OSPF 1 there, which is probably jacking things up a little bit. So let's get rid of that. And we can go back here. Let's see. Let's just show run. We got IP OSPF area 0. And the router ID, that looks good. And then we'll double check the same on this side. Oh, because we don't have the IP OSPF, that must have deleted that when we deleted the router OSPF 1. So easy fix. We're just gonna go int GI03 IP OSPF 3 area 0. And there we go. The adjacency was formed. Now we should be able to go back over here. We see that that's done. And here we go. Perfect. 3.3.3.3. We see the dead timer is less than a second. Looking good. Okay. So let's go and move on to task 3. So if we go back and take a look at what we had for task 3, we're going to configure OSPF area 1 between router 1 and router 2. And we're going to configure this as a totally stubby area. Now, if you don't remember what a totally stubby area is, we can go back. I shared this link last week, so it will be in the description for the video this week as well. We kind of went over all the different areas. We have our regular area where we're going to be sending back all the different types of link state advertisements. A stub area where we're sending back the type 1 and type 2, and then the type 3 between area 0 and into the other area. But then also it's going to be sending in a default as well into the stub area. Total stubby area is a little bit different, so it's not going to be sending in the type 3 anymore. So the type 3 is kind of just like the network summaries between different areas within OSPF. So it's just going to be sending in strictly just a default route. I think they kind of explain that down here in the summary section. Yeah, so only contains type 1 and type 2 LSAs and a single type 3 LSA that's going to be describe a default route. And that substitutes for all external and inter-area routes. Now remember, last week we ended up doing a not so stubby area, which in essence is the same thing, but does allow you to have a area service border router. And remember, that's what we did to inject the external route that was coming from that other VLAN that was sitting outside of the OSPF areas. So pretty straightforward with the configuration that's going to happen here. So let's go take a look at what we're going to be doing with that. It's going to be on interface GI00 on both of these routers. So we're going to do a area 1 stub no summary is going to be the command that we need to do the totally stubby area. We go 0/0. And pretty straightforward. It's just going to be an IP OSPF 1 area 1 that we're going to put on the interface. Nothing too crazy. And then on router 2, we're pretty much going to be doing the same thing, although we haven't created the area over here yet. So let's go, let's do the OSPF instance. Router OSPF 2, router ID 2.2.2. And then we were going to go area 1. Think that since that is just the, it's not a border router with area 1. Let's take a look and see. I don't believe that we need the no summary command there. I think we can just go area 1 stub. Okay, so should just be able to go like that. Drop that in there. I'm going to go to the interface. 0, 0. And then the command that we want for that, again, very simple. Just IP OSPF. It's going to be IP OSPF 2 area 1. And at that point, we can see that that ended up loading. So we can do show IP OSPF neighbor. And we see that that adjacency was formed. We also see that the dead timer here is obviously much longer than the 1 second that we had configured with the dead timers for area 0. Do show IP OSPF neighbor. And kind of see the difference here. So we can take a look to verify the total stubby area configuration. We can do that. We could do show IP OSPF process. I mean, not process, just do show IP OSPF. And let's see. Have router ID. It's an area border router, right? So that's a router that connects between multiple areas. And what we are looking for here is number of areas in this router 2. 1 is normal, so that would be area 0, and 1 is a stub. And we should be able to keep going down a little bit more for some more information on the area. So area 1, number of interfaces, is a stub area. And no summary LSA in this area, as would be expected since we are doing a totally stubby area. See if there's anything else that's really worth covering at that point. I think that's pretty much it for task 3. Let's go and take a look at what we have going on for task 4. So we're going to set up a OSPF area between router 2 and router 4. So here, this is going to be area 1. Oh, and I think we actually jacked the area numbers up here. I think we ended up doing area 1 up here instead of it being area 2. So we could change that real quick though. Let's do show run. So if we change it on 0 there, and I don't think that there was anything else. Yeah, okay. We'll just move that around real quick just so everything matches. Oh no. Well, what we will do is go area 2. GI 00. No. IP OSPF 1, area 1. So we'll just get this so this is all lined up with the diagram. And we can change that to area 2. Easy enough. I'll just make sure everything looks good here. Area 2 on the interface. And we need to get rid of that. That should be good. Okay, and we'll just verify. There we go, looks good there. Now let's go over to router 2. And we had this. I'm gonna go no. And we are just going to change this again to area 2. And get rid of area 1 under router OSPF 2. And so it's going to be area 2 stub. There we go. Okay. That should be good. Sorry about that, but better to get it cleared up, and it's good for troubleshooting purposes so we can kind of see how we go back and forth as far as changing stuff. Show IP OSPF neighbor. There we go. Looking good. Okay. So we're on to task 4 at that point. We're going to set up area 1 between router 2 and router 4. And then we're going to need to make sure that it can connect back to area 0. So remember, that is a concern when you have an area. All the areas need to be able to have a connection back to area 0 in order for the routes to be propagated correctly. The problem here, though, that we run into is that normally we could do a virtual link from area across another area to the backbone. The problem is because we set this up as a totally stubby area, we actually can't do the virtual link. So that's not something that is allowed. So we're going to have to do something a little bit different to make sure that that works properly. And in that case, it's going to end up having to be a GRE tunnel. So let's go ahead and get OSPF area 1 set up. And I'm just double checking my notes here to make sure that everything looks good. Okay. So let's hop in and add those into a router 2. We can go and get that set up first off. So let's see. I'm just double checking my notes here. So I think we want to go show run. We'll just take a look again real quick. So we got area 2 there. So we're going to go area 1 on this guy going down here. So let's go. I'm just making sure that we got it on the right interface. 01. And I think I might have accidentally flipped those around. So let's do this. Interface GIs as 0. And we are going to go area 1. And then let's go and do that on the other router. So that's area or router 4. And let's see, this is going to be uplink to router 4 is going to be GI02. I think that's what we wanted to do. Let's see. And we do need to do our router OSPF on there as well. So we'll do that first. Get that going. So we haven't actually done that on router 4. Okay. That's good. /2, and that is going to be area 1. And I noticed that the configs here are actually a little bit messed up. So we're just going to make sure, I'm going to correct these after the fact so that these are correct, and that's why it's kind of causing me a little bit of confusion. So let's go IP OSPF 4 for area 1. Okay, so now we have a connection between those. Show IP OSPF neighbor. Right, so we have that loaded. There we go. That's good to go. But the problem is, if we go back over here and look on router 1, do show IP route. Actually, let's go and put 03 on router 4 in that same area as well, because that's what we actually do have on the diagram. We want to make sure that it is included in that area. So we'll do that as well. And GI 0/3 and IP OSPF 4 area 1. Route. Okay, we should be able to see this 4 network on router 2 at this point. IP route. Yeah, so we're seeing it via OSPF, right? So 110 is OSPF. But the problem is, because this area 1 isn't connected to the backbone, we are not going to be seeing it in the routing table here. show IP route. Right, so that is a problem. That's why we are going to do that tunnel interface. So let's go and get that tunnel interface, and we're going to put that in area 0. So we're actually going to do it as a tunnel interface between router 2 and router 1, but we're going to put that across there. So let's take a look and see what we have for the tunnel information here. Very, very straightforward if you've never done a GRE tunnel before. Let's see. Let me just make this whatever we want to do. So in this case, we're just going to go tunnel 0 on both sides. We make up some IP space. So we're going to do 5.5.5.1 on router 1 and 5.5.5.2 on router 2. It's going to be a /30. It's going to be IP OSPF 1 area 0 on this side. On the other side, it's going to be area 0 as well. Let's see. And then tunnel source is the interface that it's coming from. So in this case, it's GI00. Destination 10.0.0.0.2, which is the IP address on the other side of this link. And then we're pretty much the config is going to be reversed going back the other way. So we can go ahead and grab this. We aren't going to add this authentication yet because that's actually something that's coming on a later task. So let's just go this. Okay. And we're going to grab the tunnel source and tunnel destination. Perfect. No shut. Should be able to do show IP in brief. And we see that the tunnel interface is up on this side. Let's go and grab that off of the other config as well. So like I said, it's going to be kind of the inverse of this. So it's going to be tunnel 0 again, 5.5.5.2. At this point, it's going to be IP OSPF 2, because that's the OSPF instance we're running on router 2. And at this point, we're then creating an area 0 on that device, which then will allow it to be able to send the routes that it needs to send. In essence, router 2 will then have a connection to the backbone. So let's do that. And we can then go ahead and grab the rest of that. No shut. Should be able to do. You can see that there was connection was made, so we actually should be able to see that as show IP OSPF neighbor now. And we see that coming across there. Yep, it's a neighbor ID. Should be able to do show IP OSPF. Should be able to see all the different areas that we have here. So we actually see that it does have a connection to the backbone and then also has a connection to area 1, which is what we originally set up, and has a connection to area 2. So area 2 was up here, area 1 was down here. One other thing that we want to take a look at, because we might have forgot to do this, was also for that this VLAN over here. Let's go ahead and throw that in area 2 as well. And that needed to be in area 2, even though it says 1. Like I said, I'm gonna go back and correct that so this all gets straightened out. We're going off of what the diagram says and not necessarily what are in the configs at this point. So we go int gi0/3 IP OSPF 2 area 2. Okay, so what that should mean is that do show IP route. So now via OSPF down here in area 1, we're seeing routes from area 2. And then if we go over here, we should be able to see both of those routes do show IP route. Yep, and we're getting 2 and 4. Perfect. Okay. Let's see if there was anything else that we wanted to do. We could do some testing just all the way from router 3. Should be able to ping those. I'll just verify it's in the routing table. Yep, we're seeing those in the routing table via OSPF. Ping 192.168.2.1 and 4.1. Okay, cool. So we pretty much have connectivity all the way through here. Now let's see. I'm gonna take a sip of water here for a second. Does anybody have any questions? They can go ahead and throw those in the comment section. All right, let's move on to task 5. So what we're gonna do in task 5 is to allow area 1 resiliency, and what that means is we're going to configure our network so that the WAN link between router 4 and router 1 is used from the perspective of if this link here goes down between router 2 and router 4, then the traffic should be able to be permitted over this WAN link so that this guy here can get over to this guy here, and vice versa. Traffic here can get to both of those in the event that that connection here goes down. So how are we going to do that? Well, we're going to actually implement some, configure some default routes. So we're going to configure a default route on router 4 pointed back to router 1. And we actually don't need to worry about messing with any type of administrative distance and stuff like that. Because if you remember the way that the routing works here, it works by longest match. So as long as the routing table has routes for the rest of this stuff, it's never going to actually take that default route over here until those routes are actually removed from the routing table because of a failed link. The second thing that we're going to do is configure a static route on router 1 that points to router 4 for this particular subnet here. But the difference between that, because it actually will be a specific route, and it is a route that's already advertised everywhere else, it will match as far as longest match, and a static route does have a better administrative distance in OSPF. So what we're going to have to do is actually modify the administrative distance of the static route so that it actually will be higher than OSPF. And by higher, I mean it will end up being less preferred. So let's go and let's go to router 4 first, and we can do just the default route going back. That should be pretty straightforward. Let's go router 4. And we can go and just pull this from the config over here. So it's just going to be a default route. Just out GI01. Very, very simple, very straightforward. Default route out 01. Okay, do show IP route. And we see that we still have all these other routes. And because these are longer match, meaning that they are more specific, these are all going to take precedence even though a static route has a shorter administrative distance. Now, on router 1, we're going to have to do a few different things. So like I mentioned, we're going to configure the static route with administrative distance higher than 110 so that the route via the connection is preferred instead. Also, the static route will also need to be redistributed into OSPF so that it's advertised to router 3 down here. So what we can do with that, go over here and look at the configurations. Let's look at the static route. So it's going to be IP route 192.168.4.0. And it's going to point out GI01. GI01 is that connection going down to route 4 or to router 4. And it's going to have an administrative distance of 150, which is higher than 110 for OSPF. Then we're going to go into router OSPF1, and then we're going to redistribute connected subnets and redistribute static subnet, so that static route ends up getting redistributed subnets. Okay. So, do show IP route. So we're not actually seeing that static route in there for the 4 because this has the lower administrative distance, so it is preferred. But if we go and let's shut down this interface GI02, and we've already proven that we can ping all the way through here, so we don't really need to show that again. There's GI02. We're going to shut this, which means that we then see this connection going up to 2.2.2.2. That OSPF state is down. Show IP OSPF neighbor. We see that we don't have any OSPF neighbors at that point. Since that was the only connection, we should be able to look at the routing table again. Now let's see. Let's see where that static route 192. They're going down that way. Let's see if there was something that I'm missing here. See if we can ping. I don't think we will be able to. There we go. Okay, so that did work, even with that connection down. So let's do a show IP route. So we are getting this from 10.0.1.1, which is router 1. And we're seeing it as a external 2 route. So that's going to be because it's being redistributed into OSPF from here. Let's take a look on here again. And let's take a look at actually at the routing table on router 1. IP route. And at this point, there we go. We see that that route is showing the static route now instead of the OSPF route. So that was able to have that failover properly over the WAN link in the event that there was an issue with losing connectivity between router 4 and router 2. So that was exactly what they wanted us to do. And let's take a look at the last task that we were looking at here. So the last one, pretty straightforward. We're just going to add plaintext authentication to area 0 using the key JBC. So last week we did MD5 authentication. This is just going to be plaintext, so it's not going to be hashed. So let's go into router 1. And we're already under router OSPF 1. We're going to area 0 authentication. And we have to do it on all the areas that are attached to area 0. As you see here, when we did that, just saying that we're going to use authentication, the fact that we aren't using authentication ended up bringing down that connection there. So let's go interface tunnel 0 IP OSPF authentication key and JBC and interface GI 03, same thing. And then we'll go throw that on router 3 down here. Router OSPF 3. Area 0 authentication. Interface GI 03. IP OSPF authentication key JBC. At that point, you see that the connection for area 0 going back up to router 1 ended up coming up. Now, the only other place that we actually do have to go still do this is on router 2. And if you remember why, that's because we have that tunnel interface over on router 2 that's connecting back to area 0. So we will go ahead and do that. Okay, so it's router OSPF 2, area 0, area 0 authentication, and then int tunnel 0, IP OSPF, authentication key JBC. And that should be good with all of that. We can go back on router 1. We see that that ended up coming up on tunnel 0. So that should be good too. Do show IP OSPF neighbor. Bam, that all looks good. Do show IP OSPF. We should be able to see area 0 is using simple password authentication. So pretty straightforward with that. And we should be able to make sure that we can ping back to do ping 192.168. Actually, let's go 10.10.0.1.3. There we go. So we pinged from router 4 back over to the IP address over on router 3. So I think that is it. I think that ends up wrapping up all of the different things that we wanted to cover in the lab today. So just a quick recap. Set up multiple areas, area 0, area 2, area 1. We ended up messing around a little bit with OSPF, dead interval timers. We ended up creating a totally stubby area. So that way we were only injecting in a default route into that. Then the next area that we created, area 1, we needed that to be able to connect back to the backbone area and area 0, but the problem was area 2 was in between that and is a totally stubby area. So we weren't able to use virtual links. We had to use a GRE tunnel from router 2 back to router 1 to be able to do that. Then we wanted to do some configuration for resiliency purposes. So in the event that the interface between router 4 and router 2 went down, we'd still be able to access the router 4 VLAN, so that 192.168.4.0 network from all the other areas. We did that by having a default route pointed back into area 0, back to router 1. And then router 1, we ended up doing a weighted static route for a specific network address of the 192.168.4.0. Because that was going to match what was already in OSPF, we actually had to modify the administrative distance on the static route to be higher than OSPF. That way it wouldn't end up going into the routing table until that specific OSPF route dropped out because we took down the interface. And also in doing that, we needed to make sure that we redistributed the subnets and static route from router 1 into the rest of OSPF, specifically in this case so that router 3 would know how to get to the 192.168.4.0. So once we got all that good and going, the last thing we did was just through some simple plain text authentication for the interfaces that were in area 0. So does anybody have any questions or comments at this point for any of that? If you find these labs useful or there's other things that you want to see us cover, go ahead and throw that in the comments section. Happy to do that. I'll probably do maybe 1 or 2 more OSPF labs. I think I definitely want to hit the virtual links. So actually doing the virtual link versus the GRE tunnel. And I think that's probably really the main thing that I want to hit on this. And then I want to do some BGP labs. I think that would be fun, dealing with route reflectors and internal BGP versus external BGP and some of the different ways that we can change the weighting of the different routes coming in. Then once we do a few BGP labs, I think it would be cool to actually do a lab where we combined a network that's running both OSPF and BGP. So if that all sounds good, let me know, and we'll keep pushing forward with this stuff. If there's any other topics that you want to see done from a Cisco CCNP or CCNA perspective, happy to see if we can throw something together because it's kind of fun. So, all right, well, if nobody has anything else, I hope you have a great rest of your week. Go get at it, and yeah, we'll talk soon. All right, take care. Bye.